This is probably the easiest topic in coordinate geometry. We are going to learn distance formula in Cartesian as well as polar coordinate. Alright, so we will be doing 6 to 7 exercise on these coordinate system, Cartesian as well as polar coordinate. You don't need to remember any formula as such in this topic. The polar coordinate system, probably you know the law of cosine, that is the only thing we need to know here. Cartesian coordinate, this just works on Pythagoras theorem. Take any 2 point on xy coordinate system, x1, y1, x2, y2, and to find the distance between these 2 points you have to use Pythagoras theorem. What is this distance? This is x2 minus x1 and this is y2 minus y1. And to find the distance of this is straightforward, x2 minus x1 whole square plus y2 minus y1 whole square root. We will start with the basic question, and as we move ahead we will increase the difficulty. So first question is, we need to prove that these points belongs to an equilateral triangle. 2, 6, 2 plus root 3 and 5. You can pause this video and try to solve it. Equilateral triangle means the distance of all these points would be same, right? 2, 4, 2, 6, 2 plus root 3 and 5, and just calculate the distance. 2 minus 2 is 0 plus 2 square 4, that is 2, and this is 0 plus 3 plus 1, this is also 2, right? x2 minus x1 square plus y2 minus y1 square under root. So this is 3 plus 1, this is also 2. So each side, length of each side is 2, 2, 2. So this is, all these points are part of equilateral triangle. Okay, second question is, find the circumcenter of triangle whose vertices are 2, -3, -1, 0 and 7, -6. Also find the radius of circumcenter. This again goes to the basic of geometry that you might have learned in your school time. You can try solving it. Anyway, I'm going to give the answer also. Let's draw the triangle. The points are -2, -3, -1, 0, 7, -6. What will be our circle? The circle which will be this connecting all the vertices. Okay, I'm not drawing perfect circle, but this is how it will look. So before solving this, right, to solve the radius of circumcenter and the coordinate of circumcenter, let's think how to solve this problem, right? Instead of directly giving the solution, better to understand how to approach, right? That's the correct way to solve any problem. Circumcenter, one thing is very clear, that the radius of this circle will be same, right? Isn't it? R, R, R. So can we think on that line? If the radius is same, can we create some equations like find the, let's assume this is xy, find the distance, find this distance, and if we equate all those distance, can we get multiple equations and can we solve that? Yeah, so we can do that. Let's try for any two side. Let's equate any of these radius, for example this and this. We can do that. This distance will be the difference of this coordinate, x coordinate and y coordinate, x plus 2 whole square plus y plus 3, right, whole square. We are simply doing r square equals r square, no need to do a square root, right? And this point will be x minus -1, so x plus 1 square plus y minus 0. And if you see this carefully, we have x square y square here, x square y square, so that will be cancelled out. and we'll be left with 4 plus 2 times 4x plus this 9 plus 6y 1 plus 2x, and y square will be cancelled out. This will become 2x plus 6y equals 4, 13. 1 minus 13 is negative 12, right? And if we solve this, x plus 3y equals negative 6, right? So this is one equation, and if we get another equation, we can easily solve it. So let's do that also. We can pick another point, this one and this one. So x plus 2 square plus y plus 3 square is x minus 7 square plus y plus 6 square. I will give the final equation here. I'm not going to solve that, you can do on your own. Alright, and after solving this becomes 3x minus y is equal to 12. We have two equations, and if we solve this, we will get the point. Let's solve this, right? So 3x minus y is 12. This was 12, not negative 12. Okay, and the other equation was x plus 3y is negative 6. So we can multiply by 3 both sides. 3x plus 9y is negative 18. Negative, positive, negative to cancel out. This becomes 10y equals minus 30, and y is negative 3. And if y is negative 3, if you put any of these equation, x will be 3. So the answer is 3 and negative 3. Circumcenter is 3, negative 3. And to find the radius of this circumcenter, you need to just find the distance between any of these 2 points. For example, this one, right? 3 plus 1 is 4. 4 square is 16 plus negative 3. So this we are just left with 3. So this is 5. So answer is 3, negative 3, and radius is 5. Let's move to next question. So question number 3. Use distance formula to show that there are 3 points, and show that those all 3 points are collinear. So these are 3 points: cosec square, sec square, 0 sec square, and 1 are collinear. So why is this coming in distance formula topic, right? The 3 points will be collinear only if those points will be on a line, right? If the points are like this, that will become triangle. And the distance of 2 points between these 2 points should be adding up to these 2 points. If we just prove that the sum of these two are same as the distance between first and last point, this point could be anything, right? Not necessarily this is A, this is B, and C. So we can just think of these points as A, B, and C. I am saying this point A, this point B, and C. AB. The distance between these 2 points will be, fortunately we have 0, 0, so that becomes cosec square theta whole square plus sec 4. Directly I will say 4, right? 4 plus 4 and square root. If you simplify this, this is what? 1 over sine square theta whole square, or 1 by cos square theta, right? Let's do it in detail. 1 over cos square theta whole square. If you simplify this further, sine 4 cos 4, so we will get outside what? Sine square theta and cos square theta, and this will be cos 4 theta plus sine 4 theta. And if you convert this into tan, it will simplify it better, right? So let's divide it by cos 4 theta and cos 4 theta. Obviously if you do this, you have to take this out also, right? So that cos square theta I'm taking, because it is going out, so it will be square, not 4. This cancel out, this is 1 and this is tan. So this becomes 1 by sine square theta, and inside 1 plus tan 4 this. Alright. So AB is 1 over sine square theta square root 1 plus tan 4 theta. The distance between A and C will be 1 and 1, right? So 1 minus cosec square theta whole square plus 1 minus 0. So let's simplify this. Sine, this will be sine square theta minus 1 by sine square theta, right? 1 by sine, so this will become like this, plus 1 square, and this is obviously cos square theta. Since this is square, so doesn't matter. We can write it as cos 4 over sine 4 plus 1, and again this we can simplify this in terms of tan, right? Because that's will be easy to add. So if we simplify cos square, if we take cos square theta and sine square theta outside, this will be 1 plus the opposite of this, that will be tan 4 theta. Alright, so AC also we have. What about BC? BC will be 1 plus 1 minus sec square theta. You can go back to this, the points, right? We are on BC, so 1 minus 0, 1 plus 1 minus sec or square theta square, and 1 minus sec square theta is tan. If you see here carefully, this part is common, 1 plus tan square theta, 1 plus tan square theta, it is 1. Can we add 2 points and get the third point? If that is true, that means these points are collinear, right? What if we add these AC and BC? 1 plus cos square theta by sine square theta, right? AC plus BC is 1 plus cos square theta over sine square theta, and 1 plus tan 4 theta. This will go up and this will become 1, right? Sine square theta plus cos square theta. So this is effectively 1 by sine square theta 1 plus tan 4 theta. Isn't it same as AB, right? AB. So sum of two distances are same as third distance. That means these points are collinear. Let's move to next question. Question 4 is related to equilateral triangle. If two vertices are given, we need to find the third vertex. The points are 0, 0 and 3, root 3. So what should be the logic of the solving of this question, right? Instead of giving the answer, let's think how to solve this problem. If 2 points are given, that means we know what distance we know, right? This thing we know. Let's calculate that. 0 minus 3, that is 9, plus 3, 12. Distance is square root of 12. And isn't it very similar as the problem that we solved for circumcenter? Distance of these two should be same as this one, right? Now we know this, the length of these sides are same, right? So x square plus y square is same as the distance of this point. Also the distance of let's take this simple point, right? X minus 0 plus y minus 0 whole square is equals 12. So we will have two equations and we need to just solve the problem. Alright, one thing is very clear, the distance of these two lengths should be same, right? So what is the distance here? X minus 0 square plus y minus 0 square. So that is x square plus y square equals this distance, right? X minus 3 square plus y minus square root of 3 whole square. I'm not going to solve this, you can do it yourself, and finally you will get y equals I'm just skipping the boring part, the simplification. Now we know this equation. Also that we can equate any of these distance equals square root of 12, right? So let's do for this point, because we have 0 0, so that will be easy to simplify. X square plus y square equals what? 12. And y is this, so now we have everything in x, and we can solve for x. That's it. If we do square, 3 and 2 minus x square is 12. X square plus 3, 4 plus x square minus 4x is 12. 3x square plus x square is 4x square plus 12, and 12x equals 12. Luckily these are cancelled out, so 4x square minus 12x is 0, or divide by 4, this becomes x square minus 3x is 0. Take x common, x minus 3 is 0, so either x is 0 or x is 3. When x is 0, y is what? Y is this one, right? 2 root 3, right? Because this is 0. When x is 3, y is what? Y is root 3, 2 minus 3, so negative, right? Negative, not 2, negative root 3. All right. And why we are getting 2 points, it's very obvious that the point can be any side, right? This can be this side also, and this can be this side also. That's why we are getting 2 points. Before moving into distance formula for polar coordinates, let's just quickly recap what is law of cosine. Okay, this is any arbitrary triangle, theta a b, that is length of this side, and opposite side of this angle is c. The law of cosine says c square equals a square plus b square minus 2ab cos of this angle, theta angle. This is law of cosine. And from this law, can you think how to calculate the distance between two polar coordinates? Let's see. Suppose one point is this, radius 1, theta 1, this is theta 1, right? This angle, this is origin, and another point is this radius 2, theta 2, this is theta 2. So this angle is what? Theta 2 minus theta 1, right? And we have to find the distance between these 2 points. Why this didn't work? Okay, distance between these 2 points. Oops, this point, right? And can you correlate with this law of cosine? This is the opposite c, right, of this angle. So this becomes again this is c, right? So this angle, this distance is c square is, this is r1 r2, so r1 square plus r2 square minus 2r1 r2 cos of this angle theta 2 minus theta 1, or theta 1 minus theta 2, doesn't matter. Cos is this, if we do negative that will be same, right? This cos theta negative theta, base is always same. This is how we calculate the distance between 2 points where coordinates are in polar form. Starting with the first basic question, or maybe if we go serially, this will be question number 5. Again, this problem is on equilateral triangle. If 3 points are given in polar form, we need to prove that those points belongs to equilateral triangle, the vertices. So what logic we need to use here? Just calculate the distance between all these 3 points and those would be same, right? 0 0 3 pi over 2 3 pi over 6, this is 3. Okay, distance between these 2 points are, what was the formula? Alright, so for these first 2 points, R1 is 0, so 0 plus 9, 9, negative, right? So R1 is 0, so this point is 0. This is 3. Simple. Again here R1 is 0, so take any of this. So 0 plus this, what, 3 square minus 0, right? This one is 0, so this also 3. This is little bit we need to calculate, right? Because here none of the radiuses are 0, so this will be 9 plus 9, right? 3 square plus 3 square minus 2 times R1 into R2 and cos of this difference, right? Pi over 2 minus pi over 6. So this becomes 18 minus 18 of cos of this 1 over 2 minus 1 over 6 is 1 over 3, pi over 3. And what is pi over 3? Half. So 18 minus 9, 9. And this is also 3. So all this side length is 3. That means these are vertices of equilateral triangle. Question number 6. The vertices of a triangle are A 1 1, B 4 5, and C 6 13, and we need to find cos of this angle. If we draw this 1 1 4 5 6 13, we need to find cosine of this point, right? This is A, B, C. Cosine of this point, cos of A. We can simply use law of cosine. Let's assume this is A, B, and C. So what is law of cosine? C square is A square plus B square minus 2AB cos of this angle. And to find the cos of this angle, it will be A square plus B square minus C square over 2AB. And ultimately this now question is finding A square, B square, C square and putting it here. So A square is what? Distance formula 9 plus 16 25. B square is 6 minus, so 25 plus 13 144, right? 12 square is 144, 169. C square is 4, 6 minus 4 is 2 square plus 13 minus 5 is 8, so 64, 68. If you plug in all these values, this will be 63 over 65. You can try matching the answer. This is the last exercise. The distance between two parallel lines is unity. Let's try to draw it. Just visualize what is happening here, right? So it says distance between two parallel lines is unity. All right, so we have two parallel lines. The distance between those are 1. What else? A point P lies between the lines at a distance A. Okay, let's take any point P. The distance is A. Okay, this is A. All right, what else? Find the length of a side of an equilateral triangle PQR, vertex Q of which lies on one of the parallel line. Maybe Q is here and vertex R lies on other sides. And also it says this is equilateral triangle. So this is one point PQR is equilateral triangle. There are two vertices. What else? This is unity. These are the important points, right? So if we have this PQ with the same distance, there is another point R. So this point, this is 1 This is A, and this is equilateral triangle. We need to find the length of side of equilateral triangle, right? So how to attack this problem? This looks very complicated, right? But if we think in terms of polar coordinate, this will be very easy to solve, because this is equilateral triangle, and assume this is R, this is R, this is R, right? The distance between two polar coordinates, we are assuming the length is R. Also one point is here, this is equilateral triangle, so the angle between two sides will be 60 degree, right? So if this is given, with this given detail, what should be the polar coordinate of P? That will be R, and this angle, right? This angle will be, let's say, theta. Okay, so this is R theta, and polar coordinate of R will be theta minus 60. R theta minus 60. So now we have polar coordinate of P, R, and Q is obviously origin. We have the flexibility because ultimately we need to find radius in terms of given information. Given is what is the point? This is A, so we need to find in terms of A. Now we have these polar coordinates. So what should we do with those coordinates? We need to look for some other details, right? What details we have? This is 1 and this is A, and with basic trigonometry, if we see this triangle, for example this triangle, right? So this is theta, so this is 180 minus theta, right? This is 180 minus theta. Sine of theta and 180 minus theta is same, so sine theta is not A. This sine will be A over R. Sine theta is A over R, because theta and 180 minus theta, sine of that will be same. Now if you know sine theta is A over R, so what should be the cos theta? 1 minus A square over R square. We know sine theta and cos theta. Why are we calculating this sine theta and cos theta? Because we have another constraint. This length, the length between parallel sides is 1. And this angle, this triangle, this angle is what? Theta minus 60, right? This theta minus 60. This is theta minus 60. This is R. So R sine theta will be 1. And we already know the value of sine theta is A over R. Cos theta is obviously this one, 1 minus sine square theta, and this again sine A minus B. We need to do sine A minus B. So our sine theta, maybe bracket, into cos of 60 minus cos of theta into sine of 60 is 1. Cos 60 is 1 over 2. Sine 60 is root 3 over 2. If you put these values, sine theta here and cos theta here, finally we will get R. I'm just giving the answer so that you can match this answer after the final calculation. So this completes the topic of distance formula. Although this is called formula, but ultimately this is the application of Pythagoras theorem, and if we talk about polar coordinate, this is just law of cosine. Keep learning, and we will meet again with a brand new topic. See you soon. Bye.